In this lesson, I would like us to solve two problems. One is on land surveying and scale drawing, and then there is another question here that is on area or part of a circle, the shaded region. So those are the two questions. The first question is here: a farm in Laikipia County was surveyed and measurement recorded in a field book as shown with the baseline AB is equals to 1200 meters. Measurements are given there. Part 1, using a scale of 1 centimeter to represent 100 meters, represent the map of the farm as recorded in the field book. Then part 2, find the area of the farm in hectares. That is the first question. Then the second question, on area, the figure below shows a circular arcs touching each other at A, B and C. The radii of the arcs AC and BC are 4 centimeters and 6 centimeters respectively, and the arc AB is a quarter of a circle of radius 2 centimeters. Calculate the area of the shaded region correct to 3 significant figures. Take pi to be 3.142. So that's the second question. Let's go to the first question. You're supposed to use a scale of 1 centimeter to represent 100 meters to represent the map of the farm as recorded in the field book. So this is what you're going to do. We shall begin by drawing this line AB. You're going to get that length, the baseline AB. So take a ruler. We start from there. So take a ruler. So we're going to begin by the baseline. The baseline is, as you can see here. So the baseline is 1,200 meters. 1,200 meters, and the scale is 1 centimeter to represent 100 meters. So that means for 1200 for AB, using that scale, 1 centimeter represent 100 meters. What about 1200 meters? We divide that on by 100, and this one you're going to have 12 centimeters. So AB, we start with AB as 12 centimeters. AB as 12 centimeters. That is what I want to draw here. I'm trying to position my ruler correctly. So that is the ruler there. So I'll draw the line from 0 to 12. So that is 12 centimeters, as you can see. So 0 is there and 12 is there. So that is the baseline. So there is the baseline. So this point here, the point here is A, and this one is B. Then from there, we shall remember the scale. All these measurements are given in meters, and therefore to convert them to centimeters, you're going to divide each one of them by 100, because 1 centimeter is 100 meters. So what about 250? You simply divide everything here by 100. So this one divided 250 divided by 100 will give 2.5. So this one will be 2.5 centimeters. So from A, we measure 2.5. From A, measure 2.5. So that is what I'm measuring. So 2.5 is, so 2.5 is here. That is why you have 2.5. So from 0, 2.5 is there. So you mark that. So this is, I will just indicate these measurements for the purposes of proper identification. So I'll be indicating the measurements there so that you can see the measurements that I'm taking. So that is 2.5 centimeters. Then after 2.5 centimeters, we move to P, 340 meters to P. 340, this one divided, you're going to have this one as 3.4. So from there, I'll put P on the upper side. That is 3.4. So take the ruler again. So 3.4. So 3.4 centimeters. So 3.4. So measure 3.4 from, that is 3.4 will be there. So this is 3.4. So draw a line. This is very big. So that is 3.4, as you can see, from 0 to here. This is 3.4. So that is 3.4 centimeters. And therefore, this point here, you label this point, this is P. So that is where you have P. So P is here. And then from there, we are going to move 400 meters. After 2.5, we have 250 meters. Now we move 400 meters. When divide that by 100, this will be 4 centimeters. That will be 4 centimeters. So from this point, remember we moved this is a 2.5, that one represented 250, then 400, we are going to measure it from here. So from 250 to move up to 400, I would like you to be very keen here. So from 250, what are you going to add in order to move up to 400? You simply add 150. So 200 plus 150, you move to 400. So from this point, because up to this point is 2.5, that is 250, you shall add 150 in order to reach 400. So 150 represents 1.5. So I'm going to measure 1.5 from this point. So 1.5 centimeters, 1.5 centimeters. So that is what I want to measure. So from this point here, so from that point, I want to measure 1.5. So 1.5 is here. So it is there. You can see it there. So that is where we have from this point to this point, that is 1.5. And that is what represents from 250 to 400. That is 150. 150 meters converted to centimeters using this scale, that is 1.5. So that is what is supposed to indicate there. So this is the point here. So you have this point. So this one is 1.5. Now we are at 400. So at this point now, we are at 400 because this is a 250 plus 150, that is 400. Then from this point, you move on the other side, 400 to Q, 400 meters to Q. 400 meters again, this one will represent 4 centimeters to Q. So that one you're going to measure it on the other side, on the opposite side. So from here, I will measure 4. Sorry, may make it to be bigger. It is okay that way. So from this point here, from 0 here, so 400. So from here you have 400, that is 4, like that. That is 4. You can see from 0 to 4 there. So we've done that. So this one will be 4, and this point is Q. That point is Q. All right. So that point is Q. Then from there, we are here now. So from 400, which is this point here, we move to 600. So what are you going to add? 400 to move up to 600. That is 400 plus 200. You get 600. So from this point, we shall measure 2 centimeters. That is 200 meters. That will be 2 centimeters. So move that. Let us measure that. So that is 2 centimeters. So we are here. So 400 is here. So now we want to move up to 600. So we're going to measure 2. 400 plus 200, which is 600. So 2 centimeters. So this is the point you're going to mark. So we mark that point there. So this is the point. And this point, this one is 2. That is 2. Now we are at 600. So at 600, we move again 150 meters to R. 150 meters to R, 150 meters to R. So on this side where we have P, this side where we have P. So to R, 150 meters. 150 meters, divide that by 100, that will be 1.5. So we measure 1.5. So 1.5. So from here, 1.5 would be there. So there we have 1.5. So from 0, 1, 1.5 is there. So let me draw that line. Move this on a little bit. Like that. So this is 1.5. So from 0, 1.5 is there, like that. So that is to R. So this point here, this is R. Then from there, we're going to move to 850 from 600. I'd like you to look at the diagram here. So we are at 400 here. Sorry. So we are at 400. This is a 400. Now we want to move to, we've moved, this one is 600, I'm sorry. So look at how we started. So from 250 plus 150, that is 400. Then plus 200, 600. So we are at 600. So from 600, we add 250 to move out to 850. So 600 plus 250, that is where we go to 850. So from this point we add 250, that is 2.5. 2.5, that will be 2.5. So from here 2.5, so 2.5 is here, so that is 2.5. Mark that. So this is a point, so here this is 2.5. Then from 850 to the right, that is 300 to S on the same side with R. So 300 is 3. We're going to measure 3 centimeters on the side on this side where we have R and P. So 300, so 300 is exactly 3 centimeters, like that. So this is exactly 3, as you can see. So from this point, that is 3. So draw that line, and this is where we have S. That is where we have S. So S is there. Then from S, you move now, you are 850, you move up to 950. So this difference, so this is a point where you have 850, so you go up to 950. So you're going to add 100 from 850 to 950, that is 100 meters, and 100 meters is simply 1 centimeters. So you're going to measure 1 centimeters. So you're going to measure 1 centimeter. 1 centimeter. So from 850 to 950, that is 1 centimeter. So we shall measure 1 centimeter. 1 centimeter. So from that point, so 1 centimeter. So 1 centimeter is here. Just mark that point, that is 1 centimeter. So this is 1 centimeter. Then 950, the left, on the other side 250 to T, 250 to T. On the other side, that is the 2.5. We measure 2.5 on the other side, 2.5. So 2.5 from here. So from that point, so 2.5, so 2.5 is there. It's 2.5 is here. So 0, 2.5. So that is how we're supposed to do it. So at this point, so this is 2.5, and that point is a T. This point is T. That point is T, like that. Then from there, from 950, this is the point, you move to 11. That is the last one. So 1100, and that is the, and since that is the last one, you don't have another one, so that means the remaining distance here from 950 to 1100, that one is 150. That is 150, a difference of 150. So you don't need to add anything here, because it will take you from 950 to 1100. It is the remaining distance up to B. So therefore, at this point now, so from 950 to 1100, that is a difference of 150. So you add 150 to 950 to get 1100. So this is where we have 950. So add 1.5, add 1.5. So add 1.5. Okay, so 1.5 from this point, this is 0, 1.5 is here. So mark that point here. So that is 1.5. So this is the point, that is 1.5 or 150. Then at this point, from 1180 to V, 80 to V, that is 80 meters. 80 meters is the same as 0.8. So if you divide by this scale, 80 divided by 100, that will give 0.8. So you're going to measure 0.8 from that point. So from this point here, 0.8 to V, and V is on this side where we have S, R, and P. So this is what you're going to do. So 0.8. So 0.8 is somewhere there, very small. So that is 0.8. So from this 0, then 0.5, 0.6, 6.7, 0.8. Yeah, that is 0.8. Yeah, 0.8. It is there. It's supposed to be there. That is why you have 0.8, 0.8. So this is 0.5, 0.8 is somewhere there. So let me draw a line. So that is the line. So this is 0.8, and this one goes to all the way to V. So this one is V. Now we have drawn everything accurately. All the points are drawn. AB is there. So you can look at these measurements here. So I'll write them in meters, like this one. This was 250. This is 340. This is 150. This one is 200. This is 250 meters. The other measurements in centimeters. This is 100. This is 150. And this one is 80. Then to S. When did we go to S? To S was 300. So this was 300, which was we measured 3 centimeters. Then the one to R was 150. This was 1.5 or 150 meters. This was 400 meters. Which one have I not indicated? This is a 250 meters, and then this point here I think is okay. So this is 150. So to B, so 1100 to B, because this one is not given. Remember, AB is 1200, so this one should be 100. That was not given. From 1100 to B, that is 1100 to 1200, because figure here is 1200. So I've indicated everything in centimeters and in meters, so that you can have a look at that properly, how I've done that conversion. Now from there, you can join these points using straight lines. So you can join that point A to B, then that one you can join it as well, then to R, to S, to V, then that one to T, then T to B, like that and like that, and then also this one can join that one as well. Now after drawing the map of the farm as recorded in the field book, let's go to the second part. Find the area of the farm in hectares. Find the area of the farm in hectares. So this is what you're going to do. We shall divide these the whole of this area into sections, and like these of different shapes. Like that shape is shape A is a triangle, shape B is a trapezium, shape C is a trapezium, then D is also a trapezium, and then there is another one here, smaller part here, that is E. That one is a triangle, small triangle. Then these shape F is a triangle, shape G is a trapezium, and H is a triangle. So we're going to get the area of each of these shapes that we've drawn there, we have identified, and then we get the sum. So let us start with the first one. I've indicated the measurements both in centimeters and meters, but in this case you're going to use the meters. So like for A, we can start with A. So the area for A is a triangle. That is the area will be a half base times height. So area will be given by a half times the base. We identify the base very fast. The base is 250, height is 340. So 250, 340. So 250 times 340. So we're going to get the sum. Let's first identify. We're going to multiply that out. Then you go to B. For B, B is a trapezium. The area of a trapezium is half multiplied by the sum of the two parallel sides, and the two parallel sides here are 150 and 340. 150 plus 340, so 150 plus 340. Then we multiply by the height. The height will be this, so this will be the height, that is 150 plus 200, that is 350. So that is 350. So you're going to add that. Then you go to C. C is also a trapezium also. So area is a half multiplied by the sum of the two parallel sides. The two parallel sides here are this 150 plus 300, 150 plus 300, like that. And then we multiply by the perpendicular height. And the perpendicular height is 250. So that will be C. Then you go to D, shape D. So shape D is trapezium as well. So area is equals to a half multiplied by the sum of the two parallel sides. Here we have this side, which is 300 plus this 80 plus 80, 300 plus 80. So 300 plus 80. Then we multiply by the height. The height is here. The height is this one. So this will be 100 plus 150. That will be 250. That will be 250, like that. So we shall get that. Then from there we can proceed to E, shape E. Shape E is a small triangle here, small triangle. The base is 100, the height is 80. Base is 100, the height is 80. So a half times base times height. So that is a half times 100 times 80. Then we go to F. F is also a triangle. Half multiplied by the base. The base is this one. So 250 plus 150, that will be 400. And then the height will be 400 as well. So 400. Then we go to G. G is trapezium. Area is equals to half multiplied by the sum of the two parallel sides. The parallel side is 400 plus 250. 400 plus 250. Then multiply by the perpendicular height is this height here. This is the height. 200 plus 250, that is 450, plus 100, that is 550. Get that? And then from there we can go to the last one. The last one is H. H is also this is a triangle. The base is 150 plus 100, that is 250, and then the height is 250. Half times 250 times 250. That is a triangle. Now after doing all that, now we can, so we multiply, just use a calculator for these. Just use a calculator for these very fast. So the first one, a half times 250 times 340, that will give 42,500. So this will give 42,500. So the second one, a half times 340 plus 150 plus 350, that will give 85,750. 85,750. And then we have the other one, a half times 150 plus 300 times 250, 56,250. And then D, a half times 300 plus 80 times 250, 47,500. Then for E, a half times 100 times 80, that is 4,000. And then we have F, which is a half times 400 times 400, that will give 80,000. G, a half times 400 plus 250 times 550, that will give 178,750. 178,750. 178,750. Like that. Then H, a half times 250 times 250, that will give 31,250. 31,250. And remember, all these meters squared. Don't forget that. All these meters squared. All these meters squared. Now the total area, we simply add everything that we have here. So we have 42,500 plus 85,750 plus 56,250 plus 47,500 plus 4,000 plus 80,000 plus 178,750 plus 31,250. So we add everything, and when you add everything using a calculator, you will get 526,000 meters squared. You're supposed to give the answer in terms of hectares, so you convert this one to hectares. And remember that 1 hectare is equivalent to 10,000 meters squared. So you simply convert 526 by simply dividing it by 10,000, divided by 10,000, and this will give 52.6 hectares. So 526,000 meters squared converted to hectares will give 52.6 hectares, and that is how you're supposed to solve that part of the question. We go to the other part, part B. The figure below shows a circular arcs touching each other at A, B, and C. The radii of the arcs AC and BC are 4 centimeters and 6 centimeters respectively, and the arc AB is a quarter of the circle of the radius 2 centimeters. Calculate the area of the shaded region. Correct to 3 significant figures. The pi is given. So you're supposed to calculate the area of the shaded region. Now when you look at whatever we have here, because you have these ones as radii, these are the arcs AC and BC are 4 centimeters, and those are the radii. So that means if x, this is equivalent to that, it is radii. So this one is 6, and also this one is equivalent to this. And the fact that you're given that AB is a quarter of a circle, AB is a quarter of a circle, then this angle here should be 90 degrees, because if it is a quarter of a circle, you have something like this angle here, these angles here are supposed to be 90, so that is just 1/4. So the angle that is there should be 90 degrees. Then the other thing you're supposed to identify is this one. This again is equivalent to this. That one is also 4. And what we need now for us to get the area of the shaded, so the shaded area will be given by the area of triangle XRY, can see it, then minus the area of these sectors. So I will name these sectors as, these are sector A, this is sector B, and this is sector C. So you subtract the area of those those are sectors of a circle, A plus B plus C. So that will give us the area of the shaded part. So for us to get the area of the sector of the circle is given by this formula, the angle, that is theta, multiplied by 2 pi r squared. So we need to get these angles because we don't have these angles here. We need to get, you can call this one theta 1, and then this one is theta 2. We can call this one theta 2. And this one we know it is 90, so that one don't have any problem. So how do we get these angles? We can get these angles by using trigonometric ratios. For example, if you look at this theta 1 here, and considering this bigger triangle XRY, look at that triangle, you can use trigonometric ratios to get that angle, because you know the opposite side. So you can use theta. So theta 1, for example, you can say sine of theta 1, this angle here, is equals to opposite side is this side, that is ry, divided by the hypotenuse, which is xy, and this will give this one is 2 as well, because that radius is, so from ry this will be 6, to be 6 divided by 10. So sine of theta 1 is equals to 0.6. So theta 1, you get the sine inverse of 0.6. So sine inverse of 0.6, that will give 36.87 degrees. So that is theta 1. Then theta 2, we can use also sine, and we say sine of theta 2 is equals to the opposite side, that angle is this side here, xr divided by xy, the hypotenuse. So sine of theta 2 will be given by xr is 8, then the hypotenuse is 10. So this will give theta will be obtained by the sine inverse of 8 over 10 is 0.8, and this will give the sine inverse 53.13 degrees. Now having those angles, now we can get the area of triangle. So we start by getting the area of triangle, the bigger triangle XRY. So that will be given by a half times the base. The base is ry, which is 2 plus 2 be 6. Then the height is rx, that is 8, and this will give 24 centimeters square. That is the whole triangle, the bigger triangle. Then we get the area of A, the area of sector A, and the area of a sector is theta over 360. Sector A, we get theta 1 is 36.87 degrees divided by 360 times pi times the radius squared, r squared. Radius is 6, so 6 squared. So this one will give so 36.87 multiplied by 3.142 multiplied by 6 by 6, everything divided by 360. So this one will give 11.58. So this will give 11.58 centimeters squared. Then the area of B, theta B has the angle there, theta 2 is 53.13 divided by 360 multiplied by 3.142 multiplied by 4 squared. So this one will give 53.13 multiplied by 3.142 multiplied by 4 by 4. Then everything divided by 360. That will give 7.419 centimeters squared. Then we have the area of C. Area of C will be given by, so C, the angle we said is 90, theta over 360, that is 90, times pi times the r is 2 squared. So this will give 3.142. Look at it, 3.142 centimeters squared. Now we have these, we have these. So we can add everything together. That is 11.58 plus 7.419 plus 3.142. So this one will give us the total 11.58 plus 7.419 plus 3.142. This will give 22.14 centimeters squared. That is the total area of A, B, and C. A, B, and C, and you can see A, B, and C. So we said the area of the shaded part will be given by area of the triangle, bigger triangle, which we got as 24. So now we are getting the shaded part. So shaded part will be given by 24 centimeters squared. That is the area of the bigger triangle. Then subtract the sum of A, C, and B. When you subtract that, we'll be left with the shaded part, and we added everything there. We got that one as 22.14 centimeters squared. So subtract that. So 24 subtract 22.14, and this will give 1.86. You're required to give your solution correct to three significant figures. So those are three significant figures, centimeters squared, and that is how you're supposed to solve that question.